This is the periodic table. Do you remember how many color groups we counted? No. How many color chunks? It was 7. You're right. We have the red group. We have the orange group. We have this entire yellow chunk in the middle. We have the green one. We have the blue one, and we have the light purple and the. Okay. Everyone, just so you know, listen up. Actually, when I was actually preparing today's lesson, I don't know if you can see it. Can I zoom in here? I know. Let me see. No, you can't zoom in here. You actually, I don't know if you stand so close. Maybe actually, even if you stand close, it's hard to see. It's easier to see on the screen. This projector makes things very bright, and when things very bright, slight differences in color are very hard to see. To all of us, all of these look what? No. Look what color? All of these. Those. Look what? They are actually given 2 different shades of blue. Seriously. And that's actually one thing we're going to learn today, is that these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 elements are actually not all the same color. Yeah. And you know what? Just so you know, if you ever end up studying chemistry, that's one thing you always have to accept whenever you're studying chemistry. Chemistry has a certain number of exceptions. Exceptions means what? You might think you understand a lot about a certain chunk, and then you find what? An exception or an exception region, as in, ooh, I have to change my rules for this chunk. It happens that these 6, if you stand really closely, you will actually see it. These 6, C, N, O, P, S, C, S, E, so this triangle right here is actually a different shade of blue than this. Yes, sir. Hydrogen is the same as hydrogen itself is paired with these blues and not these very slightly lighter blues. Okay? Yeah, hydrogen is so specific. It's grouped with something that's very far from it. But that's just how the way they were able to work out the periodic table. So, what did we say here? We dealt with group number 1 first, which is the red one. Oh, sorry. Vertical ones are called what? Come on. Vertical. The columns are called what? Groups, or they have another name. Family. And a family usually has what? Has a relation together. That's why they call them families, because lithium and sodium and potassium have a lot of things that are similar to them. Yes. And the group number is the number of what? Who remembers what this word was? Come on, everyone. I see people just watching their phones. That's not good. No, this board. Valence electrons. What are valence electrons? If Abdullah was here, he probably would say it. This is the number of electrons where? On the what? On the biggest, not big, just the last circle you sketch on the B. Rutherford diagram. Count the electrons. That's the valence. Okay. All right. What do you remember? What's the name of the horizontal ones? The vertical ones are columns or groups or families. What do you call? It is what? No, we're still doing this. We're actually doing this. Okay, they're called periods. Yes, horizontal rows are the periodic table, are called periods. And what do they tell you? They don't tell you the number of valence electrons, but they tell you the what? They tell you how many circles the diagram should have. Okay, it represents the number of electron orbitals or circles that you might need to what? You might need to sketch. Okay, all right. So far, so good. Now, let's talk about each group. Yeah, by the way, whenever you study the periodic table, you almost never study the what? The rows. You all study them in what? Come on, you never study them this way. You all study them what? Because these ones share properties. These ones don't share properties. It's always these ones that share properties. So if you study one of them, I'm not going to say you know everything about the things under it, but you know a few things. Okay? All right. So, do you remember what was the name of this group, of this part? Come on, you should have your notes. Yes, Blendon. Those are called alkali. Again, not alkali. Alkali, what? Metals. Whenever you hear the word metals, you think, oh, something solid. And you're right. So these are the properties of these guys. They are shiny. They are solid. Yeah, I have yet to see sodium or lithium liquid in room temperature. That makes absolutely no sense. So they are shiny. They are solid. They are very soft. If you touch them, not your fingers, you will not feel roughness. You will feel as if they're soft. They're like this. It's like passing your fingers on the table. Okay, passing your fingers on the table. Not passing your fingers on my hoodie. That feels rough. Silvery. What does silvery mean? They look like what? So they look like a grayish, silvery color. Okay. Form compounds. What does form compounds mean? By the way, what's a compound? I mean, I know we didn't cover this yet, but it will be the biggest thing we cover starting from next week forward. What's a compound? Can someone tell me what's the difference between an element and a compound? It's the basic thing about chemistry. What are elements and how are they different from compounds or vice versa? How is a compound different than element? We have Blendon with his hand up. Anyone thinks they know the difference? I don't care if you say the wrong thing. I love it when people say the wrong answer because that means if you think it's wrong, if you think that, someone else, or actually if you think it, great. So what? You learned something new. Trust me, you have to be wrong the first time. It's like going to the gym. You can never lift right the first time. London, go ahead. What's a compound? Sorry, what, say again? The what? Elements. Elements are pure by themselves. Compounds? Exactly. What is the smallest number of elements you need to make any compounds? 2. 1 gives you an element. 2 or more gives you a what? A compound. Can someone give me a compound made up? Yes. Let me just wait until who just went? I forgot. Yes. Let me just 2 minutes and then you can go. Can someone give me an example of? Can someone give me an example of a compound that's made up of 2 elements only? Just 2. Turk. Can someone give me an example of a compound made up of just 2 elements? You breathe oxygen, your body uses it. The cells give you back what? Carbon dioxide, which is poisonous if you breathe a lot of it. You're breathing other people's exhaling, basically. It's like a blender is breathing into me. Okay? CO2. What elements are involved here? What's C? Carbon and another what? Oxygen. 2 oxygens and so on. Does anyone here know a compound made up of 3 elements? That's got to be a challenge. If you know it, I will be really impressed. Anyone? Come on. Jaden? Anyone knows a compound made up of 3 elements? It's hard, yeah. Most of the ones you study, even in chemistry class, are made up of 2. So like, or NaCl. How many ones? How many is this? Just Na and Cl. This is salt. This is your table salt. What do you put on tea to make it sweet? Sugar. What's the formula of sugar? That's a big one. Yeah. That actually, if you're ever wondering why is carbon the most important element to life, it's because carbon is so, I don't want to say powerful, it's so special and unique. It is able to make very big what? Molecules, like very big compounds. So what does form compound mean? Makes compounds that are very what? Sorry, are usually what? If you mix lithium with something else, or sodium, or potassium, or rubidium, usually the thing they make would have what color? White. Also, it has a very other feature. Come on. What's that word? Very what in water? Huh? Yeah, soluble. What does soluble mean? Is it easy to dissolve or hard to dissolve? No. Soluble means if I put the powder, not this, you have to see it, so water. If you put the powder in the water and you swish it, that's it. You can't see it anymore. Okay? What does insoluble mean? I don't want to be talking to myself. What's insoluble? Yeah. I don't care how much you swish it. Yeah. While you swish it, yeah, it's being mixed. Put it down. Just wait for 5 seconds. Goes down. I don't care how little you put or how much you put. It will never dissolve. However, alkali metal, when they actually form powder, they're very, very what? Soluble. Okay? And how many valence electrons do they have? Last one. How many valence electrons do they have? 1. Because they are group number what? They are the first column. The first column, all of them will have 1 electron on the last circle. Okay. Well, anyone remembers the name for period number 2? Sorry, group number 2. What was the name? The first one was alkali metals. What was the name of the second one? It's almost the same name, but with extra word. It's still metals. It's alkaline, not alkali, but there's a point. There's huh? What planet are we from? Alkaline earth metals. Why do they call them earth metals? They're very common in the actual, not outside in the street, but if you go to, like, for example, a desert and you dig deep, not deep like kilometers, a few feet, you will actually be able to find beryllium, magnesium, calcium, and so on and so forth. Okay. Hold on. Who wanted to go? Robert, and after him. Okay. What are the properties of these? By the way, yes. Sahar and then you. Okay. What were the properties of these? Were they similar to the first one? If you look at your notes, did they share a lot of similar properties? Yeah, they did. Look. Shiny. Were the first ones shiny? Look at your notes. Look at your notes. The notes from yesterday.
Where does it say the name?
I told you to write the names on top.
You did?
Yes. Everyone, I told you, on top of every bubble, write the names. On top of every bubble, write the names. What does that mean? Everyone, on top of this bubble, I'm going to use this. Look at the screen. On top of this bubble right here, this bubble, you have to write here, in here, all of these. And on top, you have to write alkali metals. Okay? Do I keep chasing you, man? So why is it not out? Because we're going to finish it. I thought you lost it. You didn't bring it up. Okay? All right. So the first one, everyone, is alkali here, right here. And all of these properties go here. Okay? So that's the first one. Second one. Okay, where are these? Can someone tell me? Which ones? There's still 3 bubbles left. You're right. These are here. So you have to write under it or above it, whatever you want, alkaline earth metals and these properties. You remember the name? It was a weird name. Okay, it's okay. It's a new name. Halogen. Halogen. What properties do they have? Oh, they could not be more different than the first 2. First of all, they're non-metals. Oh, where are these? Sorry. Yes, they are still at the bottom here, and they're just called halogen. So halogen, everyone here, and you put the properties here. Now we're doing this. Oh, these we're covered today. Everyone, we covered the periodic table in 2 days. The first day we covered this, and that, and today we're going to cover all the rest of them. Okay? So what are so special about these? First of all, non-metallic. You will never have fluorine as a metal. What's the second word? Come on, what's the second word? What does poisonous mean? Good or bad? Poison. Bad. Bad. How? But those are what? Biological poisons. I'm talking about chemical poisons. These, if inhaled or actually consumed, like as a drink, you need to be rushed to the hospital immediately. Okay? React. What was that word? What does? Don't even say it. Can you tell me what it means? Or what word does it look like? Very similar to what word? Ready. What does ready mean? Quick. Which means react readily means easily. It's ready to react. With which ones? No. Where are these? Yes. Are these on the left or the right? Left. How about these? What did guys? What did I tell you about the periodic table? Guys, thank you. Shh. The further apart they are, they react what? Hard or easy? What does this word mean? Does this mean react hard or react easy? Easy. if you mix chlorine, guys, shabab, shabab, shabab. If you mix fluorine with K, with potassium, yeah, you can just mix them and they react because they're ready to react together. Okay? So they react easily with alkali metals to form salts. How many valence electrons do they have on the last circle? 7. So we went from 1 to 2 to 7. Okay. Do you remember the name for these ones? I discussed it with, was it you or was, yeah, I think so. No. Yes. What was it called? What was the name? So first of all, we know they are what? We know they are what? By the way, that's not how you put gases. Gases only has one S. Gases, one S. It's okay. Mistakes. We're science people, not English. Although spelling matters still. Do you remember why were they called noble gases? What does it mean to be noble? When you refer to someone as a noble person, what does that mean? Again, I gave you a few examples. Again, that's what Muhammad, I think, said. Loyal is the other one. Loyal is the other one who is a follower of the noble. Who's the noble though? What? Someone who's basically what? Very what? High in society. By the way, I mean, technically, let's be honest. Nowadays, it used to be very common when in the 1800s, 1700s, where in places where there was like a kingdom. Okay, nobility usually were people associated with the what? With the king or with the royal family. The royal family. They don't have to be of the royal family themselves, but they could be what? Very, very, very associated with the royal family. Okay, people who are their good friends, rich people who what go travel with them and so on. Okay, so that's what noble means. So noble means what? Very high in society. Now, technically, if someone is very high in society, are they always outside with the regular people or no? Nope. No, they travel by themselves. They have helicopters. They have, well, nowadays, they have their private planes and so on. So they don't mix with others, right? That's what noble means. Interestingly enough, they found out when they discovered those gases that they don't mix with anything. It's very hard to make them combine with another compound, no matter where it is. It's very hard to mix it with chlorine or silicon, or cobalt or magnesium. Super, super hard. Actually, they were super hard to discover in the first place because you can't do a reaction to produce it and then to see it. So they are noble gases. Very unreactive, just like a noble person is very unwilling to react with someone else or to, well, be friends with someone else. So very unreactive, which means, by the way, the first and the second thing mean the same thing. They're just explaining the first one and the second one. Very unreactive means they do not react with other elements to form compounds. You can make them react, but the process you have to do is very, very, very difficult, insanely difficult. You need a lot of specialized equipment, and you need a lot of energy. You might need a lot of heat to make them really force into each other in the bucket, whatever. Okay? Why do they, come on, why do they don't react? Because they're what? Here's the key word. They're what? It's like when you're full after a big meal. Do you want to move or do you just want to sit? If you eat a big meal afterwards, what do you want to do? Do you want to go to the gym or you just want to sit? Yeah. So why don't they react? Because they have what? Why do these not like to react with anything else? Because they have what? Full final circle. The final circle is full. When it's full, they don't want to what? Lose electrons or what? What's the opposite of lose? Win or gain. Okay, they don't want to give electrons to other elements, and they don't want to gain electrons from other elements. They are perfect. It's like saying, you know what, that's it, I'm good. I don't want to lose any money, I don't want to gain any money, I am perfect the way I am. So they don't react. Okay, I think this is what we did. Come on, this is what we did up to yesterday, right? I don't think we did the others. Okay, so now we talk about the others. All right, so okay, so this is what I want you to do now, everyone. Oh, sorry. It has to show you. Yes. Okay, come on. You have to, everyone listen up. Make sure you write this in the bubble and then you point exactly where it's pointing. Okay? Come on, everyone. Come on. Yeah. So metal, non-metal. So not a metal, like the opposite, okay? So which groups are we referring to now? Oh, sorry, no, hold on. Not groups. Which parts are we referring to? We're referring one part to what? To just what? Just hydrogen. The other part is referring to honestly, you can point it to either one, okay? Because here's the thing about this, everyone. I know that the arrows might be pointing just to one thing, but it's actually pointing to what? To a chunk of them. It's actually referring to C. Again, you just have to point here, but it actually does refer to C, N, O, P, S, S, E. Okay? Okay, so just point it there. Okay, where's the other one? Second, come on. Left. Second one, called what? Can someone read that word? It's probably gonna be difficult for some. This word. Okay, remember, when it's a tough word, what do? You what? You cut it into 2 or 3 words. Well, you can cut this into 2. You can cut it into, what's the first word? Metal. What's the second word? Lloyds. Yeah, metalloids. Metal. Let's say it together. Metal. No. Say metal and keep your tongue like this. Metalloids. Yeah, metalloids. Which one are you pointing to on the metalloid? Like which one is the arrow pointing to? Which one? B, the B. Okay. But again, is it really pointing to or referring to one element or a bunch of them? Come on. No. Like this one. This one did not just, it points to N, but it actually should everyone, pencils down. This is what I mean. This one hits what? N or O. But it's actually what? Referring to C and N and O and P and S and SE. Now, which one is this one hitting? But it's actually referring to what? B and B and SI and GE and AS and SB and TE and PO. Do you see how they're similar in color? It's referring to all of these. See, that's what I think about chemistry. There's weird cutting of the periodic table. Yes. How many bubbles do we still need more? No, how many other bubbles? 2. Other metals. Hey, that's an easy one. That's like a what? Like a bottom triangle. Sorry, triangle. Aluminum, gallium, indium, scandium. Basically, all of the real green ones. These are all green, same color. Perfectly same color. Okay, one more.
Yellow.
The yellow, the big chunk in the middle. By the way, the only thing that we're not gonna fully talk about in today's lesson is the big chunk in the middle. Okay, you only start studying it in grade 11 chemistry. It's not important in grade 10. Nope. Who can read the first word? Okay, forget the AL at the end. Forget the AL at the end. Who can read this word? No, not tion. TION at the end of any English word is what? Shin. Almost. Transition metals. I don't know what they call transitional. You can write either word, but I've always called them transition. What? I don't know. Honestly, I've always seen it transition. It's the same meaning. Transition, transitional. It's the same word. Okay? So, we're going to talk about, everyone, we are only going to talk about this, and this. We are skipping what? What was it called again? Transition or transitional metals. We'll talk about these 3. All right? So, what we have to do now, ladies and gentlemen, is this. We're going to do nothing with this. Don't worry. We're going to do nothing with this, except for one thing I'm going to show you. But all of the words will be here. Noah, everyone? What we're about to see now, you are going to put it all in here. All right. Which one are we going to talk about first? Come on. Which one is on top? Other non-metals. And it's can someone again remind me what it refers to? Like what is it pointing to? Like what elements is the arrow pointing to? First of all, which one is on the left? Blue. H, which is what? hydrogen. Which ones on the right side is it pointing to? Like, sorry. Which one is this? No, this one, this one. You have to give me more than N. It's pointing to 6. It's pointing to what? N. C. S. S. E. So it's pointing to the, do you see how it's a perfect triangle? 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. These 6, these 6. Okay, let's talk about them a little bit. Okay. Oh, we're talking about, oh, my bad. Sorry, everyone. We're talking about, oh, I edited the, okay. Sorry, we're talking about the green ones first. Do you see how these green ones are all, okay. Are these green ones different green or all the same exact green? So they're all other metals. I want you to do that. Go ahead. Yep. Yeah. Now, make a thick line, everyone. Make a thick line to separate them. Because okay, let me tell you why. Hold on one second, everyone. Look at your table here. Everyone, just look up here. Do you have colors in here? That's a problem. Here you have colors, so you know exactly where the elements are, like which group they are. Here you have to put the what? The lines, the stair. It's like going the stairs, right? This is actually called a staircase. Staircase. So go ahead. Yeah, just make it thick to know exactly that the ones we're talking about right now is this one, this one, this one, this one, this one, this one, this one. 4 and 3 is 7, 11 elements. By the way, you can either make, listen up, one way is to put this thick black line. One way is to what? If you want to color them, sure. But then that means you have to bring your own green color, your own light blue color, and then your own regular blue color. I think the stair structure is much easier because you're not always going to have colors. So make sure you do it exactly this way. You have to start from here under the B. Look, everyone. Go right 1 step. How many steps do you go down? So 1 step, 2 steps, and then 1, 1, 1, 1, 1, 1. So you only need to go 2 once. It is, yeah. Okay? Make sure you exactly copy that line. Okay. What are the properties of these ones? All right. Well, let's see what the properties are. What's the first property? They're all what? Come on. All right. Shiny means what? They are, means it's like when you shine something. Yeah, yeah. Where is it? Is it the non-metals, metalloids? Yes, everyone, this is the first one. Thank you. Metals. Everyone? Yes, everyone, this is this. All of these ones, put them here. By the way, you can put the word other on top of metals, but it's basically here. Okay, there you go. Yes. Sure, go ahead. Dunya, what does shiny mean again? Shine. It shines, okay? It's like when you clean your shoes, leather shoes, and they reflect light. They look nice. Can someone read this word? Mal, not mall. I know it looks like mall, but it's actually malleable. Malleable. What does malleable mean? Malleable means it's solid, but easy to what? It's easy to break, but it's easier to bend. Okay, if I give you right now, okay, aluminum. Everyone, aluminum. Do you remember the picture with the aluminum siding? Some houses have aluminum on the side, right? If you take, if I take you right now, okay? No, hold on. Everyone, if I take Elias right now, and let's say this wall is like the outside of a house, and it's made of what? Aluminum siding. And I take you, okay, sorry. Imagine if this is brick, right? Imagine if I take you and throw you at the wall. Is anything gonna happen to this brick? No, you're gonna break a bone or something, but nothing's gonna happen to the brick. What if this was an aluminum siding, and I throw you at it? Could you bend it? You could. Aluminum is not as strong as brick. That's my point. Brick, you cannot what? Brick, you can, guys. Brick, you cannot dent. If you're strong enough, it doesn't matter how much you keep hitting this. Are you doing anything to it? There's not even a single dent. But if you're strong enough, if you're a very strong boxer, and you stand outside of a house with aluminum siding and you hit it, oh yeah, you can definitely see that someone hit there. That's what malleable means. Easy to dent. Easy to dent. By the way, can you tell me something outside that's easy to dent and it costs a lot to fix? No, aside from house. Something outside. Cars, right? If you punch a car body, you could actually what? Dent it. Dent means what? Make like a little impression in it. Aluminum's like that. That's exactly the best example. Cars. They're made of, the panel has some aluminum in it, and that's why sometimes it's very easy to dent, unless you really make it solid. But by the way, is it very good to make a car very solid? No, because they would become very heavy. You want the car to be light, but also what? Safe. Okay, so this is what Malibu. Yeah, if you make it undentable, that means you're gonna make it like out of brick, but that's gonna be a very heavy car. And again, by the way, they make heavy cars sometimes, like a car of a president or something. Very hard to break through. What else? Good.
Yeah.
Conductors. Yes. Cables. Guys, that's all. These materials, all of these, the green ones, sorry, the green ones, are very good what? Who can read this word? Come on. Conductors of both what and what? Electricity and heat. They conduct temperature very well, and they what? And they conduct electricity very well. What does that mean? Everyone, what does that mean? If I have, by the way, does anyone know what AL stands for? I just talked about it with Elias. Aluminum. If I have an aluminum wire, everyone, look, if I have an aluminum wire and I stuck it here, I'm going to get electrocuted. Because it's what? It's a good what? Conductor of electricity, of electric current. Also, yes, also, if you have an aluminum wire and you put it on the stove, on the oven, on the top oven, and you turn the stove on, is it going to heat up? Oh yeah, it's going to heat up very quickly. Like give it just 30 seconds, and then you can't touch it. So what does that mean? It's a good conductor of both heat and electricity. So they could be dangerous or they could be good. Depends what you use them for. Okay, what else is there? Most are what? Solid at what? Room temperature. What's room temperature? The temperature of this room. Yes. Yeah. Does anyone know roughly what's the temperature of the room right now? Today is not too hot. It's good. Does anyone know? Kind of like instant. Huh? Yeah, actually I can read it. 22, 23. Yep. Between 20 and 25. I would say 23. So that means what? If I give you aluminum, would I give it to you as a liquid or as a solid in room temperature? Yeah. All of them are what? Sorry, not all. Most are solid. Some are what? Some could be liquid. I'm not sure which, but some could be liquid also at room temperature. But most are solid, which is good. Is there anything else? This, by the way, this is going to be a big part of chemistry in this course. Reacts with, who can read that word? This is one of the most important words, not just in chemistry, but in all of science. No, ACID. Okay, I'll give you a hint. Hold on. Imagine it's not a C. Imagine it's an S. Just read the word. Acid. Who knows what's an acid? Yeah, acid. Or
Like gas.
no. Acids are, yeah, acids. Most of acids are not gases. They're liquids. Do you know that there's acid inside of your body?
Yeah, that's what I'm saying. Like,
No, but it's inside of your body as a liquid, not as a gas. You said gas. Show of hands. How many people sometimes, I know, after you eat a certain meal or a certain food, you feel like you have heartburn? That means what? You have what we call what? The acid is actually what? Making you feel a bit numb. There is so much acid in your stomach. That's it. But by the way, you do need acid in your body. You know what? Do you know what acids always do? Do you know that your car battery has acid? If you actually do with car battery, it has acid. If you pour a very strong acid on, I need something metal. This is wood. On this. Okay, everyone, what is this made of? This part. Come on, this is wood. This is what we call compressed wood. Okay, it's not just, it's like, it's really compressed. It's like dense. Is this wood? That's metal. What is it? I don't know. Maybe some aluminum and some iron and I guess like nickel or whatever. If I have acid and I pour it, strong acid, and I pour it here, it's gonna eat through it. This is what they do. Yeah, go ahead. Acids make things, break things, but they don't break them by a hit. They just make them what? Dissolve away. Yeah, if you actually break it, you're actually gonna cut it, and that's, by the way, that's why they cut. Oh, I got it. They use acids a lot in industry to what? To dissolve things. Okay, but you have to be careful when you deal with acids, because if the acid gets on your skin, it could actually corrode your skin. It literally goes through it, and it could, yeah, acid again. That's why whenever you deal with acids, you do two things. Number one, you wear long gloves, thick gloves. Also, you never deal with what? With acids unless you put them so. You're having acid right now. Again, because this has so much caffeine, and caffeine, too much coffee will always make you what? Have heartburn. I know that because I drink so much coffee. Okay. What am I saying? Yeah, you put long gloves. Also, you never deal with acid unless you dissolve it so much in water. Why? When you put something in water, does it get stronger or weaker? When you, yeah, weaker, because you have less of it. So you have to deal with what we call what? Weak acid, not strong acid. You can always make an acid weak by taking just a few drops and put them in a big bucket of water. You still see a reaction, but it's not as dangerous. Do you see what I mean? Okay, let me tell you. If I fill this with car battery acid, no water, just the acid, and I pour it on your arm, that's it. Okay? But if I take this much and dump it in a huge tank of water, mix it well, okay, and then dump a little bit on your hand, you're just gonna feel a little burn. Why? Because I diluted or weakened the acid by dissolving it in so much water. No, this is not acid. I'm saying if this was pure acid, you pour it through anything, almost it eats through anything. That's what acids do. So apparently, these ones reacts well with what? Which means if you pour acid on aluminum, it goes through it. The acid will burn the aluminum. Not burn, it will dig a hole through it. Okay? All right. Anything else? Okay. Oh, found on the what? Found on the what? No. Where? Which side? Left. On the left side of this stairs. This looks like stairs. Sure. This is just telling you where it is. Come on. Found on the left side of the staircase. Okay? So that's one of them. Now, which group are we going to do next? Well, we have a choice of two. We can either do this group, blue, 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 or light blue, light blue, light blue, light blue, light blue, light blue, light blue. Let's see which one. Do you want to take a guess which one? Do you want to take a guess which one? Huh? I'm asking, which group do you think we're going to do now? The blue one or the light blue one, the one in the middle? Sure, let's see. Okay, everyone, so let's go to the next group. Sorry, I can't call it a group because technically it's not a single column. It's a bunch of them. That's the thing. It's slightly darker. It's very hard to see. That's all. Okay, let's see. Everyone, next chunk or next bunch of things. Which one? We're doing these ones. So I need to sketch another stair structure. Here it is, everyone. Sketch this one. Add this one to your periodic table on the second page. We have CNOPSSE. Okay. What are these called? The first one were called other metals. These are called what? Non-metals. Okay. Does anyone know what's C? What's capital C? What's the element that's represented by capital C? Carbon. What's N? Nitrogen. What's O? Oxygen. What's P? You remember? Something that shines at night. Phosphor. Phosphorus. Do you know what S? Sulfur. Do you know what Se? Selenium. Again, but the most important three are which ones? Carbon, nitrogen. These are the important three. All right. Who knows what the first word means? Dull. What? No, that's dull. D-O-L-L. That's dull. Yes. Yeah, oh, sorry, yeah. Everyone, these ones, thanks, Haley, these ones are the middle ones now. Non-middles. Yes. Who knows what dull means? When you're describing a color, what does dull mean? What does shiny mean? It shines. Yeah, what does dull mean? Does not shine. Does it reflect light nicely? Can you see the light in it? Not this part, the cover. Yeah, the lid. Yeah. So this is shiny. How about this? Shiny as well. How about this? Can you see the light in it? No, like at all, or can you see some light? Can you see the lamp in it? Yeah, I can see the reflection. But is it very shiny or very weak? Dull means not shiny almost at all. So dull means doesn't shine. Dull means does not shine. Does anyone know what brittle means? Give me an example. Okay, Blendon, don't tell me what it means. Give me an example of something brittle. Give you a hint. It's something you eat or you can eat. Sugar cubes, crackers. Have you, okay, every single time you eat crackers, what happens? It breaks easily, right? Brittle means something that breaks easily. Not breaks easily as in this. By the way, do you think I can break this? I can, all right? If I just enough force, I can break it. But that doesn't make it brittle. Cookies are brittle, right? Because when you eat a cookie, what always happens? Little parts fall. When something could be broken down into very small pieces, we call that brittle, okay? Oh, by the way, who has more brittle bones, me or you? No, I do. Your bone, if you break a bone, God forbid, if you break a bone, if you fall on this floor, if you fall right now, not just that, if you break it, most likely it will cut clean. So all that happens is you have to hold it in place, put the cast, and just make sure that it what? Heals and connects nicely. My bone, if it breaks, it's not gonna break clean. It's gonna break a little bit in what? In little pieces. Okay. Oh, who can read that word? Come on. 5 minutes. Who can read that word? Not insu. Okay, everyone, I'll say it. I'll say it. Insulator. In. Okay, in. And this, what's the word? Insulators. What are insulators? They do not conduct what? Or heat. When you deal with electricity, do you wear metal gloves or rubber gloves? Rubber. Rubber is always made of what? Carbon. And why? Because carbon is a what? Good insulator. If you ever touch a wire, or if you actually, everyone, if you actually have a rubber glove and you put your fingers in the socket, nothing's going to happen. Okay? Don't try it, but nothing is going to happen. Okay? Because carbon or rubber does not let electricity go through. So that's good. But if you wet your hand and you stick it here, you'll be zapped for sure. Because water is a good conductor of electricity. Yeah, nothing's going to happen. Nope. Yeah. Again, rubber does not connect electricity. That's why electricians, whenever they work with big power lines outside, they always have to wear what? Rubber gloves. Not any kind of gloves. Yeah, like a full suit. Yes. And they need that to work. Okay. They could be solids. They could be liquids. They could be gases. Even at room temperature. I'll give you an example. In room temperature, what's carbon? Carbon is solid. Carbon is coal. It's coal, like whatever you get after you burn something. Nitrogen in room temperature. I'm breathing nitrogen right now. It's gas. Oxygen. Phosphorus is solid. What's the next one? Sulfur. Sulfur is solid. They do not react with what? What was this word again? The thing in your stomach that makes you was acid. Acid. It's a C, but it's like an S. Acid. Acid. Where are they found? On the which side? On the right side of this staircase. Which group is the last one to do? Come on, people. We only have like 3 minutes. I'd like to finish this with you before the weekend. Where's the other group that's left to do? Yes, in the middle, in between them. The light blue one. That's it. It's the easiest one. It's called what? Metalloids. These are metalloids, so it's the third column. And what does it say? Have properties of both what? Because it's in between. It shares something with these green ones, and it shares some property with these ones. Also, they sit on the staircase or in between of both of them.